Okay, so we launched it. What was they gave us the initial velocity, and then we hit the height here at a vertex. And the vertex told us a couple of things, right? It told us how high that rocket hit, the maximum, the y value of the vertex. It's actually the h value because our y-axis is the height, our x-axis is the time. So our x told us how long it took to get to that y, that maximum height, right? It was very nice music. And then this is also an important point here, right? What is that? That's right. It's the x-intercept, right? That's where it lands and stops. So this is really important in life, especially like when the space capsule came down and they had to know where it was coming from. Yes, ma'am. Yes, yes. I was waiting for that. Why? Because I never do attendance on time. Then how do you know who's here? I make the other teacher do their job. See, what happens is, yeah, stop. X-intercept, okay. Also, we talked about the rate of change, right? The actual slope of our parabola. That was about it. That's as far as we got. Yes, sir. The height is the y vertex, the maximum height is the y vertex, y coordinate of the vertex. From standard form? Sure. Here's standard form of a quadratic function, right? He's asking how do you get the x-coordinate of the vertex? The x-coordinate from standard form. The x-coordinate of the vertex equals negative b over 2a. Okay? Well, what if you had to compute the vertex and you don't know how to do the calculator? Well, how else are you going to find this point? This is instant. Don't you want to know how high your rocket went and how long it took? What? No. You have to learn this. This has all applications throughout the world and life. Huh? You guys are nuts. All right, number two. All right, number one, we launched a rocket. Number two, we're dropping an object. Okay? For those of you who ever dropped like a pumpkin or something off the top of the building, you can know. Sure, we used to. Okay, what's going to change from the first one? That's right. Our initial velocity here, if I'm holding a pumpkin outside the building, what's the initial velocity? 0. So the initial velocity designated by v naught or v sub 0 is equal to 0. What else is going to be changing here? The initial height is going to be different. Initial height represented by h of 0 or h naught or however you want to say it, is going to be 120 this time. Okay. All right. An object has dropped from the roof of a 120-foot building. How long must it fall to hit the ground? Now, it takes 120 feet long to hit the ground. All right, so first of all, are we in metric or standard? Standard. So we have the h of t or the s of t. I think s of t is times, seconds, I would imagine. They want us to how long, so yeah, probably the s of t would work better. Seconds, they represent s as seconds. You can use whatever you want as a variable. You can use SpongeBob. You can use SpongeBob of t. Okay? You can use anything you want. Doesn't matter. Huh? I don't know. You can just use whatever you want. Okay, so we have the s of t. And it's in what we're finding how long it must it fall to hit the ground. So we're looking for t. Okay, so the s of t, can't you just read it? Equals time. All right, now we're in standard measurement because it says foot, so we have to use negative 16, right? We're not going to use negative 9.8. Shut up. Negative 16t squared plus, what's our initial velocity? 0 v sub naught, or v sub 0. And what's our initial height? 120. Okay, we can simplify this. Yes, you're right. You get rid of this middle term because it's 0. So negative 16t squared plus 120. So that's my function. S of t equals negative 16t squared plus 120. All right, so let's sketch what's happening here. Here's my height. Here's my time. Okay, where am I starting at? My height. That's it, 120. So I'm starting there, and then I'm dropping this. So it's just going to go. Okay, and they want to know how long must it fall to hit the ground. So we're looking for this point, correct? Because that's going to be the amount of time when it hits the ground. There's my sketch. You morons. Sure. Here. No, she's not here, is she? No. Sorry. Oh my gosh. Should have missed an important appointment. Yeah. That's scary.
Yeah. I have a question. First hour, are you still, is that the way you're?
We're looking for the x-intercept because that's going to give us the amount of time. Now, yes. So, I just started again. Maybe. All right. Good. Figure it out. Find the x-intercept. I showed you how to do it like for 3 days in a row. Go ahead, figure it out.
Is it the triangle of y divided by the triangle of x?
It's slope, and it's delta.
Isn't it 1 divided by negative?
What? Go ahead. Jacob's working on it. Jacob's doing the right thing
I
too.
don't like playing games.
It's not a game. It's a problem for you guys to solve. It's actually, I'm giving you a problem to solve for once. All right. So I typed in negative 16. I have to use x because we don't have a t on it. Well, we do, but it's hard to get to. So negative 16x squared plus 120, right? Everybody got that on their calculators? Hey, go to graph it. I get this goofy thing. I put negative 16x squared plus 120 into my y equals button. Remember, we're graphing a parabola, right? Right? It's a quadratic function. Did you get this? Yeah, when you go to graph it, you get this goofy thing. You get two lines. That's because I showed 7th hour how to do this, and they probably left it in your calculator. So, all right, so 2. All right, so I have to tell you now. Remember how we got the x-intercept? We did second trace. We calculated the 0, and then we entered 0, and we did the left bound thing and the right bound thing. Yeah, I showed you this. Okay. All right. So, the problem is this is so zoomed in. You're going to need to do this for your homework tomorrow, and this can be on your quiz. When we're really, really zoomed in because how high are we here? 120 feet. Okay, so what we have to do, Breeze, what? It's on the backboard. Okay, so we need to change our height to at least 120 feet so we can see the top of the vertex, right? So you find it? We're going to go to our window, okay? This is our standard window where it says negative 10 is our x minimum, x max is 10, and with the y min, negative 10, and the y max, positive 10. Now, we want to raise the y max to get to that 120. So I'm going to put, I don't know, 140 for the y max. Okay, I don't need to go so much on the ground. Maybe I'll do negative 4. Okay. Now, Taylor, knock it off. Okay, now, if you go back to your graph, okay, see, there's our parabola. We caught it all. But if you look at our x-axis here, we've got, it looks like it's going to be between 2 and 3. So I'm going to put my x max, I don't know, 4. Okay, so I'm going to go back to my window. I'm going to put my x max at 4. And I really don't need to go out to negative 10. I'm going to go out to negative 5. And I'm going to change my y min to negative 5. Because I want to see my cursor underneath the x-axis. Well, after you practice, do your homework, it becomes second nature to you. So now I'm going to graph. And there's my parabola. Okay? You could even squeeze this out. You could go to negative 1 if you want, because we're only interested in the positive one. Right? We're not throwing the pumpkin behind us. We're throwing it forward. Yeah, we could, but we're not. All right, so again, I want to find that x-intercept. Remember how I showed you? Go to second, trace, and I want to find the 0. Hit enter. Now this time I can actually see where my cursor is now because I got the whole parabola on it. All right. So I need to set a left bound. So I need to get to the left of my intercept, and I want to get a little close. Okay. It's a nowhere calculus. All right, so I'm going to hit enter. There's my left bound. Now I want to go underneath the x-axis to get a right bound. So there's my right bound, and it's asking me to guess. I hit enter, and my x-intercept is 2.74. And that's the answer to my problem, 2.74 seconds. That's when it hits the ground. Okay.
I'm talking.
It's like the beginning.
I know.
Metric. Okay, so we're going to have to use negative 9.8, right? T squared plus our velocity, initial velocity, plus our initial height. Okay, so we got to figure out a couple of things. Do you really need it? Jeez. Okay, maybe. I'll think about it. You are playing basketball in European League, so we got the whole metric thing. You release the ball at a height of 1.9 meters. What's that? Yeah, that's our initial height, right? Release the ball. And initial velocity, T. Can we figure out what the initial velocity is? 8.1. How many seconds until it reaches the rim, which is 3.05 meters high? Yeah, let's sketch it and figure this out. Okay, so here, this is my height. This is my time. So let's see, initial height at a height of 1.9 meters. Well, maybe it's more like this. Okay, 1.9 meters. And then you're shooting a basket, and our rim is right up here. Okay, there's our rim. So you shoot this ball, bam, hits the rim, goes through, and comes down. That kind of sketch right there. Okay, so this is our time, and they want us to figure out how many seconds, so we need to figure out when it hits the rim, right? You with me?
Yeah.
Did I lose anybody unless you're playing video games? Okay, our rim is how high? Our rim is how high? 3.05. So we know the y value already. Any ideas? Well, let's finish our equation here. Negative 9.8 t squared. We're looking for t. Our initial velocity, 8.1 meters per second, 8.1 t. And the initial height, 1.9. It's probably a really tall guy that's shooting it, right? Yeah. So there's my equation. I need the x. Looks like the x. I need this x here, right? This x or t. Any ideas? Huh? The calculator. All right. I'm gonna put my window back to standard like it always is. So I'm gonna go to zoom and hit number 6. See how number 6 says standard? I'm gonna go to standard, puts my graph back to normal, defaults it to that n negative 10. Got it? Okay, y equals, clear it out. I'm gonna put my new one in there, negative 9.8 t squared plus 8.1 x plus 1.9. Now let's graph this and see what we get. Well, I can deal with this. We can zoom in closer. We could now you don't have to because you could probably do it. It might be a little difficult, but I'm going to change my window a little bit. I know that we're only going to go up to 3.05 for our height. So my y max, I don't know, I'm going to put it at 5. Okay. I don't need to go to negative 10. Maybe I'll just go to negative 5. My x max, well, let's go back to our graph. Our x max looks like it's at 1 there. So go back to your window. I'm going to change my x max to like 3. And I don't need negative 10, maybe another negative 5. And it should zoom in enough for me to, yep, there you go. So it kind of looks like my picture here. And I'm looking for time, so I'm looking for that x-intercept, right? With me? Okay. So second, trace. I need that 0. I need my cursor is at -1, -16. See where my cursor is right now? -1, 16. I'm going to bring it closer to +1. Should bring me back into the picture. Yep. So it's asking, are you to the left of that intercept point? Well, yes, I am. Are you to the right of that intercept point? Now I am. And then guess. And the time is going to be 1.02 seconds.